So let's talk about the terms and terminology that make up this crazy world of artificial intelligence. Well, let's start with the most basic, the thing that came to everybody's consciousness, this generative pre-trained transformer. Throughout this presentation, I will provide you with the definition of those so that we can understand what this GPT, this generative pre-trained transformer, means. But we need to back up a level before we do that and look at broad terms. So I want to look at the term artificial intelligence. I want to look at the term machine learning. Deep learning, what exactly is deep learning? And then all that leads us to this generative AI. And really, the value of generative AI is when it's mixed with special content, like in the life sciences industry or the legal industry or insurance industry. And then we have applied AI. So let's look at what all these terms mean. They're often used interchangeably, but they're not really interchangeable terms. So first of all, artificial intelligence. What is it? That's our broad circle. Well, artificial intelligence is basically the theory and development of computer systems that can perform tasks that require human intelligence and discernment. It acts as a human. That's the broad field of artificial intelligence. But there's lots of subfields under artificial intelligence. And that's what we really need to think about. I think about it as maybe a field like engineering, right? You have mechanical engineering, you have civil engineering, you have electrical engineering, nuclear engineering, software engineering, all kinds of engineering, but it's all under the broad umbrella of engineering. And we have that same dynamic in play with artificial intelligence. So with artificial intelligence, you have subsets. You have a subset of robotics, a subset of expert systems, a subset of machine learning, a subset of natural language processing, and a subset of computer vision. Now, we're going to drill down because machine learning is often interchanged with artificial intelligence, and they're not the same thing. But let's look at each of these subsets. Now, one other thing I'll mention is that while in this graphic, the subsets are all spaced between them, that's not the case at all. It's really kind of sloppy. So robotics overlaps expert systems, which overlaps natural language processing, which overlaps machine learning, which overlaps computer vision. So they're all overlapping. And if we drill down robotics, we can see all kinds of examples of robotics. We have robotic surgery. Maybe if you've had cataracts, you've had robotic surgery for your eyes, or to correct your vision, sometimes they use robotic surgery, or even gastrointestinal. So lots of robotic surgery, but you also have in the manufacturing field, we're building cars with robots, intelligence. Now, also under the umbrella is this thing called expert systems. And this is where they try to mimic the knowledge and information and ideas of experts so that a novice or less expert person can gain experience. So there's maybe computer-aided diagnostics, so you can figure out kind of troubleshooting. There's computer-aided simple triage when it comes to life science or medical industry. And there's decision support systems. The military uses them, financial organizations use them to help you make intelligent decisions. So that's another branch of artificial intelligence. Yet another branch is computer vision. And that's really interesting. They have computer vision now, so facial recognition, right? Is that person a person of interest? Is that just a normal person walking around? Very controversial in terms of just scanning everyone's faces. But we also have things like tumor recognition, where in the medical industry, you can look at a tumor and over time, you can see if it's changed, grown, or what it's most like. So that's kind of interesting with computer vision. And then we also have hospital compliance and hygiene compliance. So we can use computer vision to overlap what the right procedures and processes are. And computer vision can then tag you if it's not the right process or procedure. So that's another element, computer vision, under artificial intelligence. Now, we have yet more. We have this thing called natural language processing, which is maybe diagnosing conditions. It asks you a question, you naturally respond to it. Instead of keying in information, it's speaking in information, talking to robots. Alexa is an example. She's not maybe the best example, but an example of natural language processing. And again, we are mixing robots with natural language processing and decision making and computer vision. All gives us artificial intelligence. Now, the last element I saved here, and we're going to drill down into it, is machine learning. So machine learning is a subset of artificial intelligence. And machine learning is used in drug discovery, like let's figure out these different drugs, content creation, and of course, generative AI. So what is machine learning? Well, machine learning is a branch of AI, so it's a subset of artificial intelligence that focuses on the development of algorithms and statistical models to make predictions. So when you think about generative AI and it gives you information, gives you a sentence, it's predicting the next word in the sentence. That's machine learning. And machine learning is also multifaceted. So there's subsets of machine learning. So you have artificial intelligence, you have machine learning. So one part of machine learning is linear regression. So I think it's very interesting. One part's clustering, deep learning, and decision trees. It's all related to statistics. So if you didn't pay attention in statistics class, this might be a little problematic, but not really. We can still talk about the concept. So linear regression, right? Two different variables. We want to see how similar they are, how they move toward a mean. Something like predicting the number of COVID cases in a specific geographical area, right? So that would be linear regression. And actually, deep learning uses over and over linear regression. So these are also overlapping. They're shown here separate, but there's a lot of overlap between these processes. Another way that we use machine learning is we use it in clustering, where we want to try to find out what are certain traits or characteristics of a data set. Maybe it's a group of people. If we're looking at marketing, like who are all these people coming to this website? Maybe it's understanding a disease in a population. Maybe it's predicting treatment responses. It's trying to take a bunch of data and putting the data together as the data indicates, and then drawing conclusions from those clusters of data. We also then have decision trees, and they're in expert systems. If, then, else is your most basic decision tree that you have. If this happens, then this happens. And then we have things called decision forests, which I think is really interesting. It's a bunch of decision trees all together. And then we have this deep learning. Now, before we move on, I also wanted to take just one moment to talk about the types of data. And there's two main data sets that we use in machine learning. One is supervised and one is unsupervised. Supervised simply means that we're labeling the data that's coming into the model. So we know that these are, for example, cities, or we know that these are names, or we know that these are geographical locations. The system, the machine, knows that data. We tell that, we label that data so it can sort through the data. Unsupervised basically means we don't give names to it. We say, look, here's a bunch of data. You figure out a name. You figure out how this works, right? So we let the system figure that out. Now, most systems use a combination of supervised and unsupervised data, but you may hear those terms, and that's what they mean, labeled and unlabeled as the data goes in. So when we drill down into deep learning basically is using a neural network with multiple layers. Like some people are like, why is it called deep? Is it philosophical? Why is it so deep? Well, basically it's deep because it uses multiple layers to help the computer process the information. So it's not deep because it's some philosophical thing or it's thinking like a human or anything like that. It's deep because it uses multiple layers to help the computer process data. And then it can recognize patterns, text, sound, and other information. So deep learning is a subset of machine learning, which is a subset of artificial intelligence. So artificial intelligence, then we have machine learning, now we have deep learning, which is just a subset of machine learning, and it's a subset that uses multiple passes through information, through data. And there's different types of deep learning. There's recurrent neural networks, convolutional neural networks, and something called transformers. So generative pre-trained transformer, we're talking about transformers. So what does that mean? What does transformer mean? Well, it's a type of neural network. It's a type of neural network that you have input, you have the processing through these layers, often called hidden layers, and then you have output. That's a transformer neural network. Now, in order for it to work, typically what happens is the words are transformed into numbers, which are called tokens. So if you followed any of the AI, the transformers were originally conceived to help with translations. So if you have Spanish and English and Portuguese and Chinese, they all have a word for chair, but it's not the same word for chair, right? They all have a word for chair, not the same word. So how can you translate information easily? Well, you take the word chair and you make it into some kind of number that they call tokens. So it takes words, converts them into a digital number called a token, and then it does all of this analysis to figure out, hey, if this token and this token are used in the same sentence, what's the next token, right? Why don't you have a seat in this nice desk, have a seat in a comfy sofa, a comfy chair? Like, what is that? So it tries to predict based on the context, based on the other words, based on the probability of a word happening, when that is going to be chair, right? Have a seat in this nice comfy chair. So it does that. And then for the output, it takes those tokens and reconverts the tokens back into words. And that's the process of this transformer neural network. So it takes these words, transforms them into tokens, manipulates the tokens, and then turns the tokens back into words and gives you the words in the right sequence, hopefully in the right sequence. That's a transformer network. So think of that network then as a lot of information. And imagine if every time you wanted to figure out what comes next or figure out a sentence or translate information, that you had to feed all this information into this neural network in this transformer, and the transformer would have to process it and figure it out. Then you'd have to correct it, and you'd have to go back and fix it, and then it would take a long time to do. So in order to avoid having to go through all those calculations every single time that you want to do it, train it up so it knows this is a right prediction, this is a wrong prediction, we have what we call pre-trained. So pre-trained basically is a network model, one of these networks that we talked about, that's fed data, and it analyzes that data to interpret patterns and grammar and context so that it appears intelligent, but it's done beforehand. So all of that data, understanding the relationships and everything, is already in, let's say, ChatGPT. It's already in these models, so that when you use the model, it already knows basically what the predictions are, the probabilities are. It's not learning that from the beginning, so that's why it's pre-trained. So now we know why it's a pre-trained transformer. And it's generative because it's creating answers based on what you put in, that's translated into tokens, goes through this process that's already figured out the probabilities and things, and then gives you that particular output. So here's an example of it put together. Sometimes it's often called a large language model. Why is it called a large language model? Well, it's called that because, again, we go back to translation. So this is for languages, but there's also models for large visual models, large genetic models. So there's lots of different models that are there. Sometimes they're also called foundational models as well. So the large amount of data trains this neural network, and that becomes a large language model, or an LLM, and you've probably heard about those. They're also then called foundation models. So now we have this model that basically knows how humans write to each other, talk to each other, kind of connect with each other. And now we may want to make this specific by fine-tuning the model. So we might say, hey, I want you to focus a little bit more on legal, or here's some legal information, or general like ChatGPT, or here's some marketing information, or life science information, or insurance information, whatever the information might happen to be, genetic information. So this model now is predisposed to answer questions in that particular domain of knowledge. And then what you might want to do, something like Microsoft Pilot, for example, says, okay, well, we have this model and it knows how to talk and it knows how to work with you. Now we're going to add your data to it, or we're going to run it through your data, or run your data through our model. We're going to have the two come together so that it can intelligently take what you've done and then go through our model and give you an output that's new and generative. Maybe it's a summarization of information, maybe it's a new proposal, maybe it's a new paper, whatever that happens to be. So it takes that information and does that for you. So it can take organization-specific information, merge it with the large language model that already exists, and there you have information. Now, you have this model and you have it fine-tuned to give you legal and marketing information, but there's one more step. We need to prompt the model for information. Here's another example of the different AI models like Gemini, Bard, ChatGPT. We have your company data. It's all inside of the firewall, and then we have this publicly available information outside the firewall. So hopefully, never the twain shall meet. So then we have this thing called prompting, which I was mentioning before, and that's just how you ask the model for output. You type something in, it becomes a token, goes in, goes through the probability matching, then comes back out, switches from a token to text, and there's your answer. And so that's prompting. The better you write a prompt, the more effective you are in writing a prompt, the better the information or the output that you're going to have. Now, prompting is one, adding text, but organizations now are adding pre-developed prompts. So I have an example here from a company called Vyond. And what they have done is you have a little bit of prompt, but they make animated videos. And so they have prompting for what kind of layout of the video do you want? What kind of vibe do you want? Like, do you want formal or informal? What kind of format do you want? A discussion, a monologue, that kind of thing. And that it feeds it shapes the prompt. And then when you finally hit go, it actually takes all that information, translates it into those tokens, comes back and translates that into a video, and there's your video created with that prompt. So while prompt engineering, a lot of people think about, oh, I have to write something into ChatGPT or into whatever GPT. Prompt engineering is going to go deeper in that most users of systems will simply fill in information almost like a form, and then the prompt engineering will be through the protocols that go to the large language model that will then provide you with the information. So we are not all going to have to become prompt engineers, as there's going to be a specific group of people developing those prompts for all the applications that we work with. So there you have it. You have some of the alphabet soup of terminologies related to artificial intelligence. So we have artificial intelligence, a big set of things like robotics and machine learning. And we have machine learning that uses linear regression and clustering and deep learning. We have deep learning, which is basically a multi-layered network, which is how information gets processed there. And that then generates content in generative AI. And then really the value will become matching generative AI, fine-tuning that with special content from like the life sciences information or political information or insurance information, instructional design information, how to interact with people, right? There are tools for teaching communication, which are AI, all that kind of stuff. And then that's what's called applied AI. So that's kind of the terminology. Now, one more thing before I go, I just want to mention that there's some implications of the token and of the pre-training. So one of the implications is that we have to be a little bit careful. Here's a quote that says, "My rule of thumb is not to trust large language model output unless I can independently verify it." And that's from somebody who is a senior product manager at Google's AI, Google's Bard, right? That's their kind of chat bot that they have. We need to be careful about taking everything that AI says at face value, especially because of these hallucinations. When it tries to predict, most of the time it will be correct, but not always, right? We humans sometimes think in illogical, unpredictable ways, and sometimes the information comes up in unpredictable, illogical ways. These are called hallucinations. So the probability analysis that happens in that middle of that transformer network leads to these hallucinations. And an AI hallucination technically is when a large language model confidently generates false information. So we need to be careful about that. They can be derivations of external facts. They can be contextual, logical, or both. Now, every AI company is working on solving hallucinations and making them less and less, and citing sources and all that kind of stuff. So it's going to become less of an issue over time, but it still is a glaring issue now, which means we have to remain vigilant about the output. We have to check it for mistakes and inaccuracies and omissions. And we can't take the AI output at face value. I saw one time when somebody says, "Hey, we saved all this time putting information into AI. It's awesome." Well, I always say, "Well, take a little bit of that time that you saved and turn it into verification time. Check to make sure that everything is correct before you pass it on." Lots of people have gotten into trouble for that, so you want to be careful. One other thing to think about is that tokens, as we talked about, equal words, which equals money. So sometimes you'll hear an AI vendor talk about charge you by the number of tokens or give you so many tokens a month or whatever that happens to be in your organization. One token is approximately 3/4 of a word. So 100 tokens, about 75 words. So you will be charged by the token. Maybe they'll average it like, oh, there's this many tokens per month, kind of like ChatGPT does with 4.0 right now. But the implications are that your organization may throttle or reduce the amount of interactions that your team can have with generative AI just because of the number of tokens that you use. And know that it's tokens going in, so you're typing words going in, and tokens coming out, and tokens of its processing. You put a PDF in, processes a PDF, that's processing tokens. So just be aware of that information, and it means that you need to budget for AI in the future and think about how much information and content that you're going to put it in. AI is going to be expensive. It's very resource intensive, and it takes a lot of computer processing, and that equals a lot of money, and that's translated by tokens. So I just wanted to, those terms are thrown around, hallucination, token, as part of the AI lexicon, and I wanted to make sure that those were covered. So that's some definitions of some of the more commonly heard terms around artificial intelligence.